Welcome back to International Conference 2026 on Agriculture, Engineering and Climate Smart Agriculture. I hope you had a refreshing lunch and are energized for our technical session ahead. My name is Rosina Doju and I will be hosting this technical session on hydrology, water and soil engineering. Without delay, I want to take this technical session ahead. And before we begin, I would like to introduce our session chair, Engineer Kajiram Karki sir, Campus Chief, IOE Purvanchal Campus Dharan. Also, I want to invite key note taker of this session, Mahindra Yadav sir, Consultant Agriculture Engineer, and Jigyasa Rai ma'am, who is a Senior Divisional Engineer. To set the overall context of today's discussion, we will begin with the lead speaker presentation. And for this, I want to invite Engineer Tikaram Baral sir, Joint Secretary at Water and Energy Commission Secretariat, to deliver the lead presentation. Sorry, I want to confirm the time. The lead presenter get the 18-minute time and rest get the 8-minute time.
Thank you. I think I have only 18 minutes, so I want to move straight into my presentations. So basically, I'm representing WAECS. So WAECS is recently working on preparing the river basin planning. So this is a very brief study on institutionalizing river basin plan for sustainable water utilization. Basically, how river basin plan is envisioned in Nepal and some of the insights about this river basin plan. So I just wanted to start with one of the photographs. This one I visited a few years before. It's a tunnel developed by farmers themselves 400 years before. So it's Orgeli irrigation systems in Palpa. You can visit that. So there is a long list of tunnels that has been developed by the farmers in the ancient times. And this is the recent tunnels that we completed in the Veribabai diversion project. So this is how the use of waters has been traveled from the ancient times to the present moment. And similarly, this is the traditional distribution system that was developed by the farmers based on the area that has to be covered by each sub-canals or secondary canals. And the other photo is the modernization of that system, exactly in the same way that was designed or developed by the farmers at the time. Similarly, we have some historical structures for hydropower project and also the Chandra Canal irrigation systems, which was developed almost 100 years before. I just wanted to show these photographs to mention that the water resource sector in Nepal represents the combination of deep-rooted indigenous knowledge and the host of statutory laws and regulations. Basically, the water resource sectors are mostly driven by the indigenous knowledge and management technology, and at the same time, it has been recently taken over by few rules, regulations, and institutions which has been working on modernizing those indigenous knowledge and technology with the advanced knowledge. So basically, this is the history of water that we have been dealing here in Nepal. So if we talk about the governance, basically the governance is basically for the sustainable water management, economic efficiency, and equitable distribution. So water crisis is generally considered as the governance crisis. And at the same time, our water governance and the utilization of water resources have been continuously triggered by the climate change issues. And we have been continuously facing the effect of the climate change with the death in the range of thousands, whereas the affected families in the range of millions. And although also the damage, triggered or brought by these changes, climate changes, has in the range of millions. So basically, water governance in Nepal is, it has two approaches. The key approaches are we are considering the principle of integrated water resource management, and basically the regulations that is guiding this IRRM principle is the National Water Plan and Water Resource Strategy. Also, the water resource policy that was introduced in 2022, and also the sectoral approach is that we have a private sector participations mostly in the hydropower sector, whereas in the other sectors is driven by the participation of the community in the name of water resource association or community water supply association or community forest association. And basically the enabling environment are the policy and the legal arrangement, constitutional arrangement, and the representation of the stakeholders are through the provisions of the guidelines of the policy arrangement, and whereas the accountability rests on the different stakeholders, mostly the public stakeholders or the private stakeholders who develop such systems, and the beneficiary users stakeholders, and basically in the approach of joint management or participatory management. So if we see the water sector, the Constitution of Nepal doesn't give a very direct indicators of the authority in different types of government. So we have some authority that is directly related to the federal or province or local, whereas there are some concurrent authorities in the water sector. So I don't want to go in details on this slides. So I just want to move into the river basin plan. So given that we have a constitutional arrangement that has considered that the water sectors, especially the utilization, conservation, management of the water sectors falls under all three tiers of government in different levels. Therefore, this river basin plan has been developed. So basically the policy framework for developing these river basin plans are the National Water Resource Strategy, National Water Plan, and the Water Resource Policy, whereas the policy principle is the integrated water resource management. So basically the objective of this river basin plan is the utilization of the available water and land resources in the area of water supply, in the area of providing year-round irrigation, in the area of providing, bringing the potential hydropower product, and at the same time mitigate and manage the risks associated with the water-induced disasters, and maintain the ecosystem of the rivers, and also to protect the national park and the cultural sites. So basically it has covered 6 areas under these principles and under these plans. So basically the methodology that was designed to develop this river basin plan are outlined here. Basically it takes the consideration under the climate change projections, where I will not be talking in details, and at the same time it will also consider the environment, producing a SESA document, social and environmental assessment documents, which also I will not cover, where I will cover rest part of this basin plan. Basically it carries out the basin analysis and formulate the strategies to achieve some of the objective to develop to use the optimal use of the water resource, and also carry out the economic and financial analysis of the plan that was developed. So basically with this plan, the river basin plan has been divided into 11 basins. So basically the idea is we have considered 4 major river basins as a big rivers, and at the same time 6 river basins as the medium rivers. And after that, there are certain numbers of the rivers which doesn't come under the basin of this big or the medium size. So all these basins are consolidated into the single block. So basically the 11 basin plan has been prepared, and these basin plans covered prepared under the 4 different areas. So it covers the basin status, which basically gives the characteristics, describes the characteristics of these basins, and at the same time it identifies the total water available in these basins, and at the same time also identifies the total utilizations of water in these basins. So based on that, the balance of water in these basins has been identified, and based on that the water resource development plan has been developed until 2050. So with this development plan, the strategic environment and social assessment has been carried out, and basically the atlas is just a fixes of the maps of the different basins, and showing the characteristics of this basins plan. So under this, I just want to come to the basin status. So basically, we see the catchment of this basin. Kosi River is the largest catchment, whereas annual average precipitations, the Mechi basin receives the highest precipitation among these 11. And water availability is highest in the Gandaki river basins, whereas water availability in terms of million cubic meter is highest in the Gandaki basin. So based on that, the water resource assessment of each basins has been carried out using a hydrological models. Basically, we applied ICAECSA and hydrological model to carry out the total water available in different basins based on the historical or time series data of hydrometeorological informations. So for the utilization of the basin plan, this is a drinking water. This shows that until 2050, based on the projections of the populations that will have from the data we get from statistics department. So we have a projection of population until 2050, and the demand of drinking water supply until 2050 has been identified. It shows that 3,664 million liter per day of water will be used by Nepal until 2050. So basically, the demand of the water until 2050 has been identified and is segregated based on the different basins. And this shows that the southern part of the country needs more water, then needs more domestic water supply compared to the northern part. And in the irrigation sectors, basically this river basin plan doesn't carry out the irrigation development plan because the irrigation development plan was already been prepared by the government, and the irrigation development plan or the irrigation master plan envisions or identifies that there are 3.5 million of hectares of agricultural land, which out of which 2.5 million hectares is a potentially irrigable area. And from here 1.45 million hectares has been already covered by the irrigation infrastructures. However, they are not year-round irrigation infrastructures, so they are basically supplementary irrigation infrastructures, and 1/3 of that irrigation infrastructures are year-round irrigation. So basically, the irrigation master plan envisions that by 2045, however, this basin plan project the plan until 2050, envision that almost all the potentially irrigable area will be provided with the irrigation facilities, and all these irrigation facilities will be the year-round irrigations. So if you see the total irrigated area in the table is quite little higher than the irrigation suitable area. So basically, the higher is due to the accounting of conjunctive use of groundwater and surface water systems. However, the difference is not very high. So this shows that our plan has not, identified very clearly about the prospect of conjunctive water use in future. So I think this number could have been in a bigger size if you have really considered the conjunctive use of surface and groundwater irrigation systems. And under this irrigation plan, we also have identified by 2050 around 53,188 million cubic meter of water be used by these irrigated agricultures, and so demand of the water until this period has been identified. So basically, we have carried out the water resource that has been available in this basin. We have projected the water that will be needed for water supply, and we have also projected the water that will be needed for the irrigation sectors. However, this is the cumulative total volume of water per year. We should be also concerned about the seasonal distributions of the need and the supply. So if you see the large river basin, Mahakali, Karnali, Kosi, and Gandaki, basically the demand of the supply side is much higher than the demand. So basically these four systems are comparatively on the surplus zone. But if you see the medium basins, especially during the dry season, the demand is much higher than the supply side. So basically, this river basin plan has envisioned that the total water that will be needed by the country in all the sectors will be much lower than the total water that is available in the country. However, if you go for the seasonal distributions on the monthly wise, the seasonal distribution of water is not in that line. So some season we have a huge water available compared to the supply demand, and in some seasons we will have the lower water available compared to the demand. So that's why this envisions the need of some plans that needs to to be considered, or some projects to be identified to make the water available throughout the year. So under this river basin plan, because though the consumer is the drinking water supply and the irrigation, at the same time we also have a hydropower potential here in this country. So the construction of the hydropower projects will also create some barriers or some easiness to projects that under the irrigation and the water supply. Based on that, the hydropower development scenario has been designed. So basically, the baseline scenario is the optimal baseline scenario. That is based on the National Planning Commission documents. That National Planning Commission document says that by 2050, the government will be able to produce almost 48,000 megawatt of energy. And we also have a scenario 2 is on a very lower side of the scenario, where there is a projection of NEA that until 2050, 21,000 megawatt of energy will be sufficient to fulfill the national demands. And we also have a medium scenario. So basically 3 scenario has been carried out to model. So under these 3 scenario, the water diversion at different locations and the water available in the different locations has been preserved or placed in the models. So under this, the baseline scenario says that by 2050 we will be producing 47,950 megawatts. So basically, it only considers the projects that has been already under construction, and it identifies the greenfield project that will be available in the different part of the river basins. So with this, we also have a scenario 2, where scenario 1, where the optimum development of hydropower will be considered under 37,000 megawatt, and also we have a scenario where the lowest side of hydropower development can be 21,000. So basically, the development scenario will give you the locations of the greenfield hydropower projects. So basically, this is the picture of the greenfield hydropower projects. So based on that, the water that will be needed by these hydropower projects will be assessed, and then based on that, the project that will be needed for the river basin plan or needed for the other sectors are identified. So with this, I think to conclude my presentation, I would like to say that the river basin plan has identified the deficit of water in different periods, especially in the medium rivers. That's why the plan has identified some projects that can regulate the flow in these medium river basins. So with this, I just want to conclude by saying that the basin plan provides a strong strategic foundation for the basin skill planning in Nepal by promoting multi-sector coordination, prioritizing investment, and incorporating environmental flow, climate resilience, and disaster risk reduction measures. And challenges related to limited legal background for basin institutional, overlapping mandates across federal, provincial, and local government, capacity constraint, data gaps, and weak financing and implementing mechanism need to be established. And finally, it is recommended for strengthening the legal and institutional status of river basin organization, enhancing intergovernmental coordination under Nepal's federal structure, improving data and knowledge systems, and linking basins plans with investment programming and monitoring framework to translate planning objective into effective on-ground outcomes. So basically, based on this river basin plan, the government is able to draft a water resource bill, which is basically guided by this plan, and will identify the arrangement that need to be made to address these constraints or challenges associated with the implementation of the river basin plan. Thank you very much.
Thank you, Tikaram Baral sir, for the insightful and contextual presentation. We now move to our first technical presentation, and for this I would like to invite Dr. Shiv Kumar Jha sir, scientist at Nepal Agriculture Research Council, to present his work.
Okay, thank you, and everyone, namaste. I'm going to present today about adaptation and performance of solar lift irrigation in Nepal farming system. It's not working. Okay, it's not working. It's not here. Okay. Okay. Thank you again. So I'm going to present adoption and performance of solar lift irrigations in Nepal farming system. Basically, we started this project from our Nepal Agriculture Research Council, from the National Agriculture Engineering Research Center. But we failed to continue this project for some circumstances. And later, PMMP provided the, he took the fund there, and then we continued this project from PMMP in the year 2080-81, where we studied the current status, adaptation, performance, and future possibility of solar lift irrigation. Everyone we know that the solar power primarily used for solar power pump as a renewable energy in agriculture. Approximately 1,600 solar irrigation projects was found. It's not working. Oh, I'm not looking there. Okay. No, it's not. Yeah. Okay. Okay. So 1,600 solar irrigation project was installed by different governments and NGOs for the sustainability, cost effective, and give the alternative to diesel for the irrigations in remote hilly and Tarai regions. We have a potential of 432 gigawatt of solar energy over a 300 and sunny days. So we conduct the study in 5 provinces: Kosi, Madhes, Bagmati, Gandaki, and Karnali, where we observe, we prepare the checklist to develop an quantitative data. Quantitative data and qualitative data was retrieved through the key information interview in 30 sample where in all the province we conduct FGD. And finally, we conduct a working group meeting with the expert team. These are some photos. We take the current. We study the current status, how it's working, and then later, we also visited some big solar irrigation projects like Mithla Solar PV project in Janakpur, Dhansa. It was a 10 megawatt power plant. It is NEA grid connected. And we monitor the technical specifications of pumps and the solar systems, which we concluded in the table, and we found that the input, most of the solar systems installed was the DC inputs, and some of them have both DC and AC inputs. Even some of them have the AC and DC inputs. They do not using the AC inputs. Only they are using the DC inputs. And what we found that most of the power generated DC inputs was 2.2 to 2.5 kilowatts. And the output was 1.8 to 1.3 something kilowatt was the output. So most of the solar systems, the farmers have the similar solar panel, similar power of solar panel. And what we concluded from our study that they have 50% of the farmers have their individual ownership. In groups, they took the ownership of 37%, and industrial ownership is only 13%. Most of the solar irrigation system installed was in working condition. It is about 86.7%. Only few, 6 to 7% are looks like not working, and 6 to 7% are can work after some repair and maintenance. If we talk about the cost sharing about these projects, so people are still not trying to. Okay, people are not still doing this, installing on their own cost. They need the subsidy, and what we found that the subsidized and the people they contributed have 71% share in installing. And what we found that most of the solar systems are the source of most of the solar systems are tube well, and 21% of them are they have the well near the rivers and then taking the water from that. About 70% of the solar systems are using for the irrigations. Even 16.7% are using for the drinking also. That project is also shown that they are doing the irrigation. And while we are talking about the impacts, what the impacts that make in because of this project, we found that in most of the places, it looks like 92% yield person says that they have increased the yield after these projects. The cropping pattern has changed there, and income has increased by the farmers. And they have given combined reactions. Some of them say that they need some training. They say that they need to make the multi-use of these projects because they are using this solar energy for the few times only, 1 or 2 times for the irrigation. So, and 40% says that they are satisfied with these irrigations. So what we concluded that solar irrigation technology holds a lot of promises to reduce the energy and water scarcity and provide year-round irrigations. There are many paths to live a solar lifestyle. We must understand the industrial application of the solar. Besides solar pumping, operations of agriculture machinery as well as establishing agro-industries could create an efficient solar energy system right at the farmstead so that the farmers could get multiple benefits from the same systems. And then we take our conclusion to the expert team, and what the expert team suggested that the discussions and opportunities for solar, we discussed the opportunity of solar irrigation on the agriculture ecosystems, where sustainability and right-based approaches to irrigation water management in the context of climate change has been discussed there. And they suggested that we can go for three ways. One, we can use the use of hybrid models, where we can use, that is maximum power point tracking, MPPT, where we can use DC, AC and DC both inputs, solar and diesel generators, PV winds, and battery tank. We can do these things for the hybrid model. Second thing, we need to conduct extensive research to understand what type of capacity and what type of machine can be operated from solar lift irrigation systems in the uptime when you are not using the irrigations. And then upgrading, we can update the existing system for the grid connection, which are still already continued in some projects. Thank you very much.
Thank you, Shiv Kumar sir, for sharing your valuable research findings. Now we will be moving to our second technical presentation. And for this, I would like to invite Dr. Indra Lal Kalu sir, Consultant Agriculture Engineer.
Namaskar to all once again. My presentation is on enhancing agricultural production through soil amendment and subsurface drip irrigation system in hill terraces. Now, after some 50 years of service, now I am working as a farmer. So I have not put anything name, just my name only. I have worked at different position. So my village side is something like that. Not the exact one, but I got from EI, but this is like that. Kata, huh? Kata? Sorry. Actually, this paper, as I said, rather than the research paper, I have just put as a discussion paper. How can we contribute to the farmers? Farmers at the remote area, in the hills. This is my theme. Main thing is, I want to share some of the information and on the problems in agriculture, water management, especially, and I want to share some learning and experiences that I have got. So in this presentation, I have just also try to present some potential, affordable, optimal ways to make farming sustainable. It may be little contradictory to what was been presented before, because I wanted to go for the very small, low-cost technology that can help the farmers. And in this paper, I have just put 4 contents. One is climate change. I have just gotten a chance to work for the climate change, climate resilient landscape and livelihood project. And the second thing is of use of biochar, which is now being more popular, and how it can contribute to water and nutrient management. Thirdly, on the study of drip irrigation, what I have done in a one research, farmers field research, and then I am just suggesting how can we convert it to subsurface drip irrigation. Because the time is short, it may be a bit, I may take more time, but I will try to finish in time, and then I hope you may ask some question if you are interested in the question and answer session. Main thing is climate change is increasing, the temperature is increasing. Second thing is rainfall pattern has changed. In the long past, the rainfall was to be just like a drizzle. So it was short duration, long duration, low intensity rainfall. But now it is just like a thunderstorm, but for short time. So the runoff also occurs, and there is a opportunity time for water to enter into the field. Infiltration time is very low. And plant wilt even after few days of drought, because there is less water is going to the field. And second thing is use of biochar. Biochar is charcoal actually. Charcoal activated with some organic manures. In India, they are using Jivamrit. Here in Nepal, they are using cow urine. That also works. So its action is, it is carbon rich. Now if you go to field, they will say, oh, hamara mato usar bhayo. Usar means something like infertile, compact, it's just like stone, no? So because there is no organic matter, farmer has stopped applying organic matter. That is one thing. And this carbon This totally carbon charcoal is like that, and it remains inert for 1,000 years. This is in the paper now. And it is highly porous and light. It improves soil fertility. Soil fertility means it doesn't contribute to the, it is not a nutrient rich, it is carbon. But when we enrich with the, this Jivamrit and cow urine, something like that, it gives nutrient. And another thing is, it can hold nutrient, and whenever the plant needs, it can supply. Otherwise, it used to be leached down. And its water and nutrient retention time is 2 to 4 times higher. When you don't apply, compared to that, if you apply, means its retention power becomes more. And another main important thing is, because there is carbon, it means it support for the microbial growth. And that microbial growth can even reduce the demand of tillage. Because if there is a more of earthworms and something are coming up and down, soil is always loose. So why should you go for that? Please think of this. And another thing is, there is carbon credit. Carbon sequestration also occurs from this. I think we can earn something like 8,000 rupees for something, I will tell later. And in that way, it increases crop yield. If I am just speedy, this is the biochar, the same function I have told. And yeah, this is the same function in the picture. Now what it is? And main thing is, in our country, soil is acidic. You all know probably, no? This biochar is nothing new. It was a past history. It was developed in millennia. I mean, in Amazon, it has been practiced for thousands of years before. So the same thing, we are reinventing the wheel. We are not doing something new. Its main thing for our country, just like humic acid, its pH is something like 8 to 9 or 9.5, something like that. So if you apply that, means it can also replace the use of this lime. No need of liming. It can improve the soil pH and make nutrient available. Do you know, phosphorus and potash are not available. Even if you apply, plant cannot take when the pH is low, something like 5 or 4.5, something like that. So it can improve this thing. So, and it can be made from all waste, organic waste. Even the straws and this Banmara, I think you know, Banmara, Lentina, Camera, and different weeds are there here in Nepal. We can burn them and we can use that. And even the manures, from the manures and straws also we can use. Also the industrial waste, whatever organic waste. For example, the sugar cane waste, and this thing can be converted to the biomass. This has been done in Hyderabad. I am also a PIC in Heartfulness Meditation Center, and there they have been doing. I will show some picture because, and that Hyderabad rainfall is just 400 millimeter. So dry, and this is the picture. In 2016, it was like that. The other side, left side, before. Now, after this, they planted all trees. But before that, they used to put biochar and organic manure. So now they have made such a rainforest. I have just been to Hyderabad and saw this. In Nepal also, research in biochar has been done in NARC. This biochar, they have said that pH is 9.8, organic component is that, and they said it can increase the yield by 12% when only organic manures are used. In that case, using of biochar can contribute to this much. And they said that one cow can produce something like 100 kg of urea in 1 year, cow's urine. So, and if for the available number of cows in Nepal, if we apply like that, you know, how many years? If you apply that way, we need not buy, it can produce something 270,000 tons of urea. So there is no need of buying urea, no? That is what is being very short in Nepal. And one thing is, another thing is, yeah, this is something like that. A farmer could earn just with one cow and using the biochar, he can make 8,000 rupees carbon credit, which they can claim for. And now in the drip irrigation. Why drip irrigation I am talking is, drip irrigation is water efficient, we all know. It is being, in NITP now, what is the name of that called? I think it is still the NITP. Yeah, they are being doing. And what I am trying to show is, in the farmers' normal field, they apply water by this furrow irrigation. Because there is no certainty of when they will get water, they apply water to the full, fill the furrow. And they apply like that, this way. I think you all of you have seen that way, that thing. And after that, what happens, they apply a lot of nutrient also. But because they apply more water, the water pass through the ridge and then that is soaks. It dissolves the nutrient and nutrient convert into the algae. Thank you. And drip irrigation, the field remains dry and it remains good. So I am showing that, maybe you may know some of these old scientists, that there is a good high yield of, from the drip irrigation. This is a table. In this table, actually what I want to say is, yield is not much different. Slightly in drip irrigation we got good yield, but water use is almost 20% because there is to apply water from channel was difficult at that time. So we could apply less water and still the yield was more or less comparable or even more. So this is same I have already told, I have no time. And what I am suggesting is in there is subsurface irrigation. It is said that subsurface is better because in that you need, the water is not wet, and now people are doing the fertigation also. Fertigation means applying fertilizer with the water. When you apply water in the surface, it will remain in the surface. But instead of that, if you can inject that inside to the root zone depth, then it can be more effective. So in that, what I have said is, I am suggesting is, we use pegs in the drip irrigation, in the surface drip irrigation. I am suggesting, could you put the macro tubes to collect the water from the emitters and then pass into that. It has not been developed. This is my just suggestion. I can try, you can try, all can try, and if it works better, we can advise to the farmers. Thank you, because the time notice has come. So if anything is there, you please ask. I am just making it very short. Thank you.
Thank you, Indra sir, for the practical and informative insight. Now we move to our third technical presentation, and for this I want to invite Engineer Birendra Kumar Yadav sir, Senior Divisional Engineer at Department of Water Resource and Irrigation.
Okay, thank you. Namaste and good afternoon. First of all, I would like to welcome all of you on my presentation on role of on-farm irrigation structure in sustainable irrigation management, a case study of Chitaha Minor Canal Kamla irrigation system. Basically, this study is based on the field learning when I used to work in the Kamla irrigation system. And my outlines of presentations is like this. Nepal is an agricultural country and it contributes about 25% in our national GDP, but irrigation is the major input for increasing agricultural production and productivity. In national context, irrigation structure is already developed for about 63% of our irrigable land. However, on-farm irrigation structures remain limited in developed irrigation system. On-farm irrigation structures play a crucial role in sustainable irrigation management by improving water use efficiency, optimizing the distribution of water level in the field level, and ultimately higher level of service to the water users. Global experience suggests that the sustainability of the irrigation system relies to a large degree on the level of the irrigation service they provide to the farmers. On-farm irrigation structure help in increasing crop diversification, cropping intensity, increased overall production, productivity, and eventually farmers' gross income. Enhanced farmers' incomes motivates farmers to pay for irrigation service fee, contribution in canal cleaning, and protection of existing structure in the irrigation system, and thereby help in the sustainability of the irrigation system. My study area lies in the Kamla irrigation system. It is the direct offtake from the main canal of Western Kamla irrigation system, and our study area is basically Chitaha Minor Canal. This study area covers only about 60.2 hectares of land, but it has number of irrigation structures like flow control structures, which controls the flow in the field, and service road for the agricultural product transportation, and our division box for the division of water in the field. Yes, actually, we have a highlighter. Okay. This red line represents the main canal, and the blue line represents the minor canal that offtaking from the main canal, and the green line represents the field channel that is developed along the field. From this field channel, we irrigate each and every field individually from the field channel. Actually, in most cases in our irrigation system, our irrigation practice is field-to-field irrigation system. But in this minor canal, due to this existence of field channel, we can irrigate only to the field which is needed irrigation, and that saves the water in the field. And in this study, I have taken as a primary source of data as a key informants of the irrigated area, and focused group discussion, field observation, and questionnaire survey to the water users. And for secondary data, I have gone through few literature of review and secondary information. And findings on the based on my methodology for the on-farm irrigation structure in Chitaha Minor Canal, based on 15 years of users' experience. Actually, I have taken some indicators like social conflict for irrigation water use. After OFIS, we can see it gets minimized to 0, and each farmer started to get water on time. And for a special equity in water distribution, adequate water on scheduled time, and equitable water distribution to the tailings. Basically, I am just going what has been experienced after the on-farm irrigation structure. And for irrigation service fee collection, almost 100% irrigation service fees collecting on that area, and almost 90% of the farmers are satisfied with that irrigation service. And crop diversification is also seen very high in that area, and farmers started to shift from high value and high yield variety. Also, we can see from the field that the paddy yield after the on-farm irrigation structure, it is significantly increased for the paddy and wheat. Similarly, for the cropping intensity, it had increased significantly, and for field application efficiency, high field application efficiency due to the field channels and control structures. Field application losses are minimized significantly. And farmers started cleaning the canal with their contributions. Almost all, 100% of farmers are participating in the contribution to clean the canals. And they are also taking the participatory decision making and compliance of all the decisions made by the committee. We can say by the use of on-farm irrigation structure, quality service with assured supply and equitable distribution of water in the canal can be provided. With this, it builds the trust and confidence among users to grow high value crops and ultimately high income. Due to high income, users' participation, ownership and development and increased IS service obtained from the system, and it will finally help in enhanced operation and maintenance of irrigation system and leads to sustainability of irrigation system. This is our study area during the paddy time. We can see all the fields seems uniform, and it has got the uniform water in the field. Similarly, this field channel, we can see from this field channel, from each and every side, both on right and left side, all the fields get water from this field channel, not to field. This is the recently grown wheat in the field area. This is mustard cultivation, and this is the mixed cultivation done in the study area. And this is how the farmers are contributing to clean the minor canal. And in conclusion, on-farm irrigation structure can be instrumental to minimize the water conflicts among users and inclusive decision making with quality service of irrigation. On-farm irrigation structure is crucial for efficient and equitable distribution of water and management of water to the tail ends. On-farm irrigation structure makes farmers independent to adopt crop diversification and shift to high-value crops. Efficient and timely irrigation results high land and water productivity. As drought frequency is increasing, it is important to have lower level canal to optimize the irrigation efficiency. As in our previous presentation, it has already mentioned that due to climate change, we have frequency of drought and flood is increasing every year, so we may have to consider the on-farm irrigation structure for the better resilience. Reliable irrigation, participative decision making, high income from the farm motivates them to pay service charge and maintaining the canals, with minimizing the government financial burdens of maintenance, and finally self-sustainability of the irrigation system. Finally, although this on-farm structure shows it is a small structure, but it has multi-dimensional impact in the participatory decision making, group ownership, compliance of rules, efficient water distribution, conflict resolution, canal cleaning, ISF collection, and finally the sustainability of the irrigation system. And based on this study, we have way for systematic development of on-farm irrigation structure is essential for providing the higher level of irrigation services in all developed irrigation system. And for the climatic resilience, conjunctive use of water with on-farm irrigation structure is crucial for achieving additional yield and ensuring year-round irrigation. Thank you very much.
Thank you, Birendra sir, for highlighting important field level and policy relevant aspect of water resource engineering. Moving ahead, we have our fourth technical presentation, and for this I would like to invite Engineer Pravesh Yadav, Associate Organizer at Ministry of Water Supply, Irrigation and Energy, Kosi Province.
Good afternoon, everyone. Namaste. Hello. So, today I will share field verified evidence of from hill agriculture in Kosi province demonstrating how irrigation directly influences crop yield farmer, using crop cut survey as a practical and scalable assessment tool. Taking keynote that this is our just initiation of a study, not a final result, and this work is grounded in real farm fields, not models alone. So table of content. Moving forward, in Nepal, agriculture remains the backbone of livelihood, engaging more than 57% of population and contributing about 24% of national GDP. However, a structural constraint remains solved. In case of Kosi province, while nearly 27% of land is cultivated, but only 8.5% of river receive irrigation throughout the year. This mismatch between the land and water access is one of the strongest driver of food insecurity, income instability, and migration, particularly in hill region. So, hill region, hill agriculture is characterized by complex topography, fragmentation, land holding, and highly uneven access to irrigation. As a result, productivity varies widely, even within the same crop and season. So to address this problem, we turn a simple but powerful tool, crop cut survey. The study is firmly anchored within global national policy frameworks. At the global level, it contributes directly to SDG 2 on zero hunger, while reinforcing SDG 1 on poverty reduction, SDG 6 on water security, SDG 13 on climate action, and SDG 15 on land sustainability. Sorry. So, can we hear? Okay, thank you. Done. This is our study area, the map of Kosi province, which is taken from Ghimire et al. And generated by Dr. Saroj Karki, 2026. This green shows that irrigated area, and then blue rain-fed, and others. So our study area is Chandamona irrigation project, Konkai irrigation project, and the Samkha district. So our central resource, sorry. So our central resource question was stated forward but important. Can crop cut survey reveal the true contribution of irrigation to agriculture productivity? Significantly, we aim to quantify irrigation-induced yield gains, analyze cost of production, test whether the crop survey can serve as a reliable evaluation tool for irrigation project. So, talking about the methodology and data sets, we applied crop cut survey directly in farmer fields to measure the actual yield and outcome. This was complemented by production of cost analysis, comparison across irrigation project and location. Secondary data set was national statistics, provincial records, and literature review. So let me now share what data revealed. Result. So the result clearly demonstrate the plot shows that irrigation shift yields distribution upward. This is not limited to increasing average yield. It also reduces variability and risks, which is clearly critical for a smallholder farm in hill irrigation system. Rain cloud plot shows that higher mean yield under irrigation. The empirical cumulative distribution function indicate faster yield cumulative across irrigation project. Most importantly, most importantly, the Lorenz curve. Lorenz curve analysis show reduced yield inequality. So, when comparing across the irrigation project, consistent yield advantage are observed where water delivery is reliable, management and effective. This highlights an important lesson outcome depends not just infrastructure but on functionally governance and operation. This is the economic implication. Yield gains alone do not tell the full story. By integrating production cost, we assessed economic performance from the farmer's perspective. The result shows clear difference between economically efficient and inefficient project. So this is the cost performance index. A positive cost performance index indicates high profit with relatively low production cost. A negative index reflects efficient investment. This metric allows planner move from blanket investment to strategic prioritization. So, coming to the conclusion, this study confirmed that the crop cut survey provides reliable, practical, and field-based estimate of irrigation impact. The state agriculture statistics support the feasibility. Studies improve the policy formulation, guide efficient resource allocation. And the implication of a study. So we have some limitation, lack of standard government of Nepal and government of province norms for crop cut survey. Crop cut survey of each location level and each MIP is not available with us. Lack of previous data, less data for eastern region or other comparison in different factor analysis. Some of our field works during the crop cut survey of different MIP of Sankasabha district, Konkai and Chandamona. So here is our reference for secondary data and data analysis. Okay, thank you.
Thank you, Professor, for that well-structured and practical presentation. We are now in our final technical presentation, and for this I would like to invite Engineer Abhishek Malla sir, Manager from ICAECSA.
Good afternoon. I'll try to be as brief as possible. My name is Abhishek Malla. I am managing the energy portfolio at ICAECSA. And being at this conference has been very enriching to me because I come from an energy background, and I think this morning I've learned a lot. And I'm glad to be here, so I'm like sitting here throughout the day. My presentation is on satellite-driven integrated energy planning for sustainable irrigation system. So I've been hearing all the presenters here, and we have been talking a lot about irrigations. And this is something that we have developed to help accelerate irrigation deployments. So why do we need this kind of software or platform? The first thing is we have been saying that almost 40% of our cultivable land do not have access to irrigation. But do we know where are those lands? Where are those opportunities? And what kind of investments is required? And what kind of enabling environment is around those areas to prioritize those sites? So this kind of information is provided by this platform. The next thing is when we do planning and budgeting, because we have heard about planning and budgeting here, are they data driven? Like, can we eliminate guessworks? And this kind of platform that uses geospatial data, field data and advanced model really helps us to do faster planning, accurate budgeting. And then the third part is when we can use this kind of digital platform for demand aggregation so that we can avoid our manual process, because there are a lot of time-consuming manual process when we collect demand at the provincial level. The amount of information when we collect the demand is not sufficient to characterize the budget and the site, which leads to decisions that might not be very cost-effective, and we might not do a prioritized deployment of our budget. So this also helps like avoid duplication, and a centralized tracking system provides, much more, better execution of our implementation. So to do all of this, we developed a platform called PURE. PURE stands for Productive Use of Renewable Energy. So this is a innovative digital platform that is designed to support decision-making for identifying irrigation requirements. Currently, the model only runs for river water at 3rd tier, but we are further developing this into groundwater and other models by harnessing satellite imagery, field data, and advanced models. So how does this work is basically at the input side, we have more than 21 set of data extracted from satellite and derived parameters, and there are 4 set of models. These data are then processed into suitability analysis. For instance, like which of the lands are suitable for agriculture depending on slope, soil types, and so on. What is the irrigation water requirement? So there is a irrigation water requirement model at a district level. And the cost estimation, because that's a very important thing, and that was quite complicated to do a cost estimation for irrigation, but we somehow derived an empirical formula using a lot of public data on, because we have a lot of public bid documents and a lot of executed projects, so we derived an empirical formula on that. It also provides like a cost, a model on pump power calculation, and then on the grid source selection, because there might be grid accessibility, but the extension of the grid might be so expensive that you might have to go with an off-grid system. So through this processing, the outputs that are generated is what are the potential area for lifting water from river, what is the estimated power that is required, and whether that is from grid or off-grid, depending on their distance and economics, and what is the estimated cost for that project, and it also generates a pre-feasibility analysis report. The way we went to this is it has been a very deep consultation process and a lot of validation with the major departments and the ministries and the stakeholders. And a lot of update has gone through, and this has been under development since 2023. And finally, it has been adopted by the government of Nepal. It's currently housed in Alternative Energy Promotion Center. And this is some of the key insights that has been generated by the report. So the platform. So the platform has identified that almost 1 million hectare of land can be irrigated through river lift systems. And if we look at the crop water requirement of vegetables, so because the power requirements differ with different crops, approximately 900 megawatts of energy would be required. And translating this into jobs, around more than 113,000 jobs can be created around this sector. If you look at the platform has 2 analysis. It has a home window and an analysis window. The home window basically allows the user to understand what is the irrigation potential in the area of interest. And the area of interest can be at the national level, it can be at a provincial level, it can be at a district level, or it can be at a municipality level. So we have not gone into ward levels because there was a lot of disparity in the ward level boundary mapping. And you can select, what is your grid proximity. You want to have a grid proximity of 3 kilometers or a kilometer or a half a kilometer. And you can also select the type of the crops. Depending on that, you'll get all of these results. And then you can also visualize those results using different layers that is available in that window. So that is at a macro level. So here is an example, like for Nepal, as I mentioned, almost 1 million hectares is the potential, and the estimated power is around 904 megawatts. And that's the cost that is required to build these projects. And similarly, if you are a planner at a provincial level like Karnali, you know what is the potential area at Karnali, what is the power that is required, and what is the cost. And similarly, if you are at a municipality level, or a rural municipality level, you would know your potential. But just knowing the potential, that's a good reference. But then when you are working at the ground, there is another window called analysis where it allows you to do microsite analysis. So under 2 minutes and 4 clicks, you can generate all those results. And those results are, you can map the command area, you can select the crops, the irrigation requirement is built in the system, you can click from where you want to draw the water and where you want to, lift the water to. It will calculate the power requirements, it will do the cost estimations. It will also tell you what is the water available in the river. So we have mapped the water availability in the river, and we have only put like third level river, which is around 100 liter per second throughout the year. It also identifies you the nearby markets. So where are the vegetable markets near your area in terms of municipality and in terms of district, so that it gives you an idea of what is your opportunity for sales, and it also provides you the grid. So all of these reports can be generated within like 2 minutes, and this helps to do that pre-feasibility sort of study or a report for your budget planning and also like site evaluations. What we did was we ran a survey of around 120 government engineers that were working with irrigation projects across the 6 provinces of Nepal, except from Madhesh, because there we do not have a lot of opportunity for river lift irrigation. What we found was to generate that report, almost 60% of the respondents said that it will take up to 50,000 rupees, up to 5 to 10 days, and up to 4 to 5 resource persons. So now all of this is translated to 2 minutes and free. One of the case studies that I want to present is, now this has been used, there's multiple use, but one case I can present here about Karnali. Here is their potential, and the distribution across different municipalities, and also at different heads, and how much can be powered by grid and how much can be powered by on-grid. So last year we did a implementation at the Karnali province, and they used this platform for documenting or generating documents for the projects that were already budgeted. And it was also validated that the cost that was generated from these platforms were very much close to the DFS, the detailed feasibility study cost. This year they came back to us saying that we are going to collect our demand. So last year we started where we had already collected the demand, but this year we want to initiate this process as a demand collector. So a couple of weeks ago, we did a very good exercise with Karnali province, and the demand collection were digitized into this, which they are now going to uptake it to their budget planning system. So that is one of the success stories here in Nepal. And similarly, because of the success, we have scaled this to Bhutan. So Bhutan government has already adopted this system and they are using it. And this year we'll be developing the system for Bangladesh. So with that, I would like to end my presentation, and we'll look for answers during the question and answer. Thank you.
Thank you, Abhishek sir, for sharing the valuable insight on Pure platform, its uses and its application. We now move to we will open the floor for discussion and question and answer session. I kindly request all the participants to keep their question brief and relevant to the session theme. And to facilitate this discussion and question and answer session, I would like to request Kajiram sir to facilitate this session.
Namaste and good afternoon. I am Kajiram Karki, session chair. It's already, and I like to thanks Rojina. Yes, Rojina. She did all my baggage. It's a session cheers what I had to do here. She did all of, that's my responsibility. Thanks, Rojina, once again. And then now floor is open, and I think it is for 20 minutes?
Yes.
20 minutes for question and answers. We took, I don't know whether what time permits us, but we are leaving the time its schedules. So we took 4, 5 something questions. Please, but that's questions to short and focused. And I like to request, please raise your hands and name your names, state your names and affiliations. And that questions to whom you are requesting that questions, including this main presenters and other presenters. That is, in total, there are 6 presenters. Please, to whom you are requesting that questions, please.
Thank you, Chair. I have, queries for all the presenters, and I'll be, but then I'll be very brief. Let me begin with the lead presenter, and all these questions are, for the sake of me getting educated. Okay. Tikaram sir, the question directed to you are 3 quick questions. One, what definition do you use in Department of Irrigation or Water and Energy Commission to call it year-round irrigation? Okay. The reason I'm asking is, there is a lot of ambiguity and claims and counterclaims. Okay, on area that we have under year-round irrigation in the country. Now, the second question to you is, when we are, talking of river basin planning, where do small water systems stand in that planning framework? The reason I'm asking this is, lot of our daily routine water use, it comes through a small water system. Go to Tarai, it is essentially small ponds which serve bulk of water need of people. Okay. So, where does it appear in the planning framework? And the importance that it holds, I remember, when I taught Birendra Kumar ji, I motivated him to work on pond system in Tarai. Now, third question to you is, sir, these days, we do not have institutional container for groundwater in the country. The Groundwater Resources Development Board, which earlier existed, is now merged to Water and Energy Commission Secretariat. Now, being at Water and Energy Commission Secretariat, how are you looking at groundwater use in the country? How are you continuing with the work, that Groundwater Resources Development Board was doing earlier? Now, the second question is directed to Birendra Kumar ji. It's fascinating to look at your presentation. And you really, brought to the surface something which is grossly ignored in, development of surface irrigation system in the country. Now, my query to you is, was this change happening when you joined Kamla irrigation system, or you really worked through the process to bring that change? Now, the reason I'm asking this is, if you look into Madhesh, the most resistance in surface irrigation development that we face in Madhesh is, with regards to sharing land for development of little water channel. People would do anything, but they would not spare that little land, to develop field channels. So how could you lead the process? My third question is to, Pravesh ji, fourth presenter. The work is that you carried out is wonderful, okay? And are you still a student at Purvanchal campus doing your master's? Is it coming out of your master's thesis? Or Kosi province is actually directing you to, develop this methodology and use it? Okay. And my last question is to Abhishek Mallaji from EC Mode. In your presentation, sir, you quickly came up with the statement that, the potential of river lift irrigation system in Tarai is low. Now, what is your logic of, making this assessment and eventually coming up with the statement? Now, it is challenging my understanding. I mean, if you look into Tarai, Tarai is not a homogeneous landscape. From Chure to southern border, okay, if you look into Chure-Bhabar zone, most of our river systems there, they are fairly shallow. Now that creates opportunity to, build a little dam to abstract water. But when it comes to inner and southern Tarai, it goes in deep cutting. And anything that is possible is, lifting that water, to create irrigation facility. Thank you.
Thank you. Thank you, Shukla sir, for these questions. With due respects, I call Engineer Tikaram Baral for answering that questions. And if I understand correctly, all the questions normally largely related to the groundwater. Please, Tikaram sir, be focused on the questions and to answer.
Thank you, Shukla sir. I recall you teaching us long time before, asking the same type of questions. But this time I am well prepared. Okay, regarding the year-round irrigations, this is the questions that struck a lot when we finalized the irrigation master plan recently. In the irrigation master plan, it doesn't talk about the year-round irrigation, the indicators of the year-round irrigation system. So basically, the year-round irrigation systems in master plan in 1990 consider cropping intensity as an indicator. So in 1990 irrigation master plan, the cropping intensity from 175 to 210. It has different categories. A different category for farmers managed irrigation system, and the different category for agency managed irrigation system. Again, in agency managed irrigation system, a different category for intensive irrigated facilities and extensive irrigation facilities. So basically, if you have a infrastructure developed until the water course, the cropping intensity should be 210 to be a year round in those systems. So basically, that was the indicator that was used in 1990 irrigation master plan. In the recent new master plan, it doesn't talk about how you measure the irrigation master plan, but it says in a different way. What it says is that all the potentially irrigable area will be provided with irrigation facilities, year-round irrigation facilities. And the cropping intensity of these irrigation facilities will be 230. So basically, according to the master plan of 2019, which was updated in 2024, if a irrigation facility has irrigation cropping intensity of 2030, then it is a year-round irrigation. That is what it has been mentioned in the document. Now, next question is about the small water system. Basically, when we calculated the
1 clarity, is it 224% or 230%?
230%. And regarding the small water system, basically the irrigation master plan, the river basin plan took all the informations of the irrigation master plan into the river basin plan. So in the river basin plan, what we did is we we categorize the total area into different zones. So basically, hilly areas, mountain area, Torre area, and we calculated the crop water requirement of different small systems, especially the farmers managed irrigation systems. And these crop water requirements were lumped into certain areas. So based on those areas, the crop water requirement on these lumped area were used to calculate the water that is needed. But it has not considered in details about the small farmers managed irrigation systems. That's why in the River Basin Plan and this proposed Water Resource Act, we have introduced a new term, usually we have not used before. We call it water accounting. So basically, we are considering the water accounting a new tool that will carry out the inventory study of all the farmers managed and the agency managed irrigation systems. And the water use of these systems will be, lumped under the certain basis that will be used in future. So basically, this is the idea on this small water system. And regarding the groundwater system, we know that the board has been already resolved, and while resolving the board, the decision was that the resource component of the groundwater will be carried out by the WEX, and the implementation of this groundwater component will be carried out by the Department of Water Resource and Irrigation. So considering the resource component, WEX has been recently restructured, and under the restructuring, we have already introduced a groundwater section under the WEX, and at the same time, there was a resource center under the ministry, and that the resource center under the ministry has been already annexed to the WEX. So WEX is, and also the WEX has already established 3 river basin office in the 3 different locations. So the size of the WEX has already been increased, and the institutional arrangement for groundwater resource has already been, in place. Though the activities, the programs that need to be carried out for the resource of groundwater most probably will be carried out from the next fiscal year. Any more questions, sir?
Thank you, Tikaram sir. Tikaram sir, please, being a lead presenter, asked one, to make ease for you so that you again do not come into the stage. One more questions for Tikaram sir so that he could leave and then come to the next. One questions for Tikaram sir, any from this floor? Yes? No? One questions? One more questions for Tikaram sir? No. Thank you. Now, please go for next.
Yeah, thank you, sir. Actually, these field channels were built on 2010. Yes, it was developed during the ILO program. Yes, but it is developed by the farmer participations and with the farmer contribution. Even the land was given by the farmer free of cost, but fortunately it is still existing, it is safe. That is the very good thing to see there. Thank you, sir.
Hello. Thank you, sir, for the question, respected Shukla, sir. Actually, I am working as association organizer under the Ministry of Water Supply, Irrigation and Energy, Kosi Province. And this is our initiation of a study. We are working in a team with Senior Divisional Engineer Dr. Mahesh Yadav and Senior Divisional Engineer Raman Parajuli, also SDE Umesh Sujaku, sir. And that's it. This is not my master studies. That's it.
Okay. Now, sir, Abhishek Malla.
So why excluding Tarai? So if you look at the physiographic division, so Tarai is around that 300-meter altitude belt. And when we are doing our validation at the ministry and at the Department of Irrigation, we were requested by the government to eliminate that because they have a swallow tubal and deep tubal planning in that area. So that was one of the reasons why we had discarded that area. Thank you.
Okay, now next questions for 2-3 questions that we took. Please, sir.
This is regarding what Kallu told. He talked about subsurface irrigation. Subsurface irrigation actually practiced 15 centimeters down. They lay pipes. You can see in Bisa, if you want to go to Ludhiana, Bollag Institute of South Asia, you will see paddy grown completely, wheat grown, corn grown, no single water, no wheat. Okay, there are 2 lines they put, and they're drip irrigation, but no need to worry about nozzles getting clogging. There's a special algorithm made how to flush it out. 10 years, they are not changed the nozzles underground. This is one. Second thing, Dr. Kalu again told about subsurface irrigation, put a pipe and test it. This has been done for last 3 years by farmers in the South India. For coconut, what they do is, it's available in Amazon also. When you look for, I think it's watering stick. If you look for it, it's available for about 100 rupees. You pipe, and around 20 centimeters, 30 centimeters depth water goes. The figures are, drip irrigation reduces around 50% water. This reduces another 50%. So it's very good for orchard. You go for, this is actually root zone irrigation, what we call. Thank you.
Please, sir. Hello, volunteers, please help.
Thank you very much. You gave me time to speak something more. Yeah, actually, sir, I just heard, I did that experiment with the drip irrigation for the potato, something about 2007 and 2008 in under one project. I didn't know, I have read in the book, but I have not done that. Huh? But somehow I got a chance to do for the NARDE fund, and I tried that. At that time, people said, he is more educated and he may be crazy. You are asking drip irrigation for potato? It should be for cucumber or something like that. Huh? No, that time was there. Now we did it and we found some massive result. And in one plot, I could not show because of time limitation. The yield was something 4.2 ton per hectare. That is only one plot because it was a farmer's trial. No? So how did they do? In that system, the main thing is from small canal, how to get to water to the tank, because that they have to bring. They have to carry and put it, and in water supplies, I mean, even in 15 days or 20 days, they get the water. So that was a difficult thing that we did. And you are very right, subsurface drip irrigation. And what I mean to say is, last 15 days or something like that, I saw in YouTube, well, they are saying in Gujarat, they are doing drip irrigation in potato. I think I did something like 15, 16 years before, somehow, I don't know. And now my saying is, you are right, I didn't know about that system. And there are, you see, somebody is using the water bottle, making the holes on that, and some are doing this clay pots, tear up these plots. And so, then I said, so I saw, I have also done, and they are using the pegs, plastic pegs to keep hold of these pipes, no, not moving. So there, as you said, you have to flush different time. So if you could use surface pipes for applying water inside, that could be much simpler because we could flush in our surface and then let the water go where is needed. Thank you for your comments. Yeah, good.
One more thing you made excellent on biochar. Biochar morning also somebody was talking about lot of biomass wastage. Actually, you'll be surprised. I was surprised to learn 60% of banana waste is biochar. India faces. So that is very good biochar you can make out of this biomass. This is one of the best utility. Thank you.
Sir,
Please,
the time is...
okay.
I don't want to say. First,
Please try to finish it within
yeah.
1 or 2 minutes.
First, I would like
Okay.
to say that in the Baralji's paper, the irrigation suitable. From my perspective, because I am living at the high hill, and you see, all of us know that in the high hills there is spring water, springs, water is spout or something like that. That is just discharging 1 liter or half liter per second discharge. And when I worked as an irrigation engineer, I said, oh, not feasible. I would like to go for something where the water discharge is 1 liter, 1 cubic feet per second or something like that, 30 liter or more than that. Because we want to cover large area, no, not a small one. But if you go for these small water points and get water from that and give water to the high hills, we can irrigate 100% area. You please think of that. Because these people who are living in the high hills also are authorized to get the benefit from the government service. But for our easiness, we just leave them. Please think.
Thank you, sir.
Thank you, sir. Thank you. Thank you. Thank you all of the participants that we honored the time. It's exactly, that's 8 seconds before that we conclude question and answer session. And if some queries or something that still may persist, but we may discuss in other off-time periods. Now, please, Regina, proceed on.
Sir. Thank you for such an engaging question and meaningful discussion. I now invite our expected session chair, Mr. Kajiram sir, to share his session remarks and key reflection from this session.
Thank you, Regina, once again. All the respected dignitaries, participants, and largely agriculture engineers that's gathered over here. It's given me for 10 minutes and I try to capture all the sessions recap. Actually, this agriculture engineering and climate smart agricultures, it covers a wide range, and particularly for this hydrology, water and soil engineering, as it is, as all of we know that this water and soils are the two main fundamentals for the climate resilience. We talk largely from farmers to the data-driven policy, that we talk in a diverse dimension, from farmers to modeling, simulations, that's equations, calculations, all of these. And that's the data-driven planning and decisions. We largely discuss about the water basins. We talk lots of on the hydropower, irrigations. Also, we talk about the infrastructures, governance systems, data forecastings, and on-farm practice. Also we discuss about the water management system, especially the drought preparedness, that is flooding preparedness, energy management, that's smart and climate-friendly smart agricultural system, that's the soil reclamations or soil amendments, especially for the biochar, and that's new technology for adaptations and performance of solar lifting irrigation system. Also, in a lead presenters, being a joint secretary in a WEX, he largely talk about the policy frameworks, also discuss about the SDG. We cover almost all in this 5 and 6 research presentations. And lastly, I took 1 or 2 minutes more because today I feel so privileged to be here to take part as a session chair. Is in the previous delivery, they said that in Nepal, that's in the eastern parts, in the Dharan, there is one engineering college. And I see lots of graduates from engineering colleges are the participants over here. It feels me so proud. And I highly honored Dr. Shukla sir over here, who did almost all we are the students of Shukla sir. And at that time, I just entered 25 years back in Purvanchal campus Dharan as an assistant professor in civil engineering departments. Dr. Shukla sir did lots of labors, especially intellectual labors to uplift that Purvanchal campus. And right now we are here, all the participants, we are the products of that campus. And today I took this munch of this stage for what we are facing in a Purvanchal campus, though it is not the forum to say something about that Purvanchal campus, but being only one engineering college in Nepal where that's agriculture engineerings are taking place in that college. Every years we took 48 students, but since last 3 and 4 years, that students admissions rate is drastically decreasing, and we are facing that problems. And among all of you participants here, and I request, since 2000s, we started that agriculture engineering, and it is a 25th years, that is the silver year, silver jubilee. That's we are going to celebrate. We are planning, and we request from this forum, maybe at the end of this fiscal years, we try to gather all the our alumni, that's graduates from that college, and I again request all the alumni that graduate from this Purvanchal campus. And lastly, again, I thanks all the participants, especially of this Nepal Society of Agriculture Engineers, NSAE and IDE, that is possible to conduct that huge international conference on agriculture engineering and climate smart agricultures. And I am highly privileged, and thanks to call me as a session chair over here. Thank you.
Thank you, Kaji sir. We are now coming to the end of this technical session, and before this we have a token of love distribution session and distribution to all the participants, session chairs and keynote takers as well. For this, I would like to invite Melina Kharel ma'am from IDE and Jagannath Tiwari sir, Joint Secretary from Ministry of Agriculture and Livestock Development. For the token of love session, I would like to invite all the participants. So I would like to call Tikaram Baral sir, our lead speaker presenter. And similarly, I want to call Dr. Shiv Kumar sir. And along with that, Dr. Indra Lal Kalu sir, Engineer Birendra Kumar Yadav sir, Engineer Pravesh Yadav sir, and at the last, Engineer Abhishek Malla sir. Now I would like to request our distributor to for the Kajiram sir and Mahendra Yadav sir, along with our Jigyasa Rai ma'am. I request all the presenters to come on the stage for a photo session. Ladies and gentlemen, this brings us to the conclusion of Hydrology, Water and Soil Engineering technical session. On the behalf of organizing committee, I sincerely thank our session chair, distinguished speaker and all the participants for making this session a success. We will now proceed to a networking tea and coffee break. And I kindly request all the participants to be back on time for our next technical session on post-harvest and agri-entrepreneurship in 5 minutes. Thank you.